Welcome to our deep dive into quantum physics and computing. We're going to be exploring some excerpts from David Deutsch's The Fabric of Reality,
Yeah.
a book that you sent to us. And honestly, I got to say, this book, it really makes you kind of like rethink everything you thought you knew about, well, everything. You mentioned wanting to understand how quantum physics and computing connect
Yeah.
and what makes them so groundbreaking.
Right.
And Deutsch, he definitely dives into that.
Yeah, the connections really are profound. Deutsch argues that to really understand these fields, we need to shift our thinking
Okay.
from just memorizing facts to grasping the underlying theories and concepts.
Right. Like instead of getting lost in, just like a sea of data
Yeah.
about planetary orbits, like we can use Einstein's theory of relativity to understand why planets move the way they do, one theory to explain countless observations.
Exactly.
It's a way more powerful way to approach knowledge.
Yeah.
Would you say?
Absolutely. It's the difference between knowing a bunch of trivia and actually grasping the fundamental principles governing the universe. And Deutsch really emphasizes that good theories don't just predict outcomes, but they explain why things are the way they are.
That makes total sense. I mean, think about like a weather forecast.
Yeah.
We want to know why they're predicting rain, not just that it might rain. And this brings us to something else that I thought was really interesting in the book, this idea that reality is so much more than what we can see and touch.
Yeah, Deutsch argues for realism. The idea that things we don't directly observe, like atoms, forces, even the laws of nature themselves, are still a part of reality. He introduces this fascinating concept of shadow photons as evidence for this hidden reality.
Shadow photons. Okay, now I'm intrigued, but also a little lost. How can something be real if we can't even detect it?
Yeah. It's kind of like, you know those invisible forces that shape our world? Like you can't see gravity,
Right.
but you know it's real because you experience its effects every day. Similarly, shadow photons are undetectable directly, but they interact with the photons that we can see,
Oh.
influencing their behavior in a way that reveals their presence.
So they're like those behind-the-scenes stagehands in a theater production.
Uh-huh.
We don't see them, but they're essential for creating the show that we experience.
That's a great analogy. And these shadow photons, as Deutsch calls them, they're more than just a theoretical curiosity. They suggest a reality teeming with countless counterparts of every particle we observe. It's a hint of something much bigger than multiverse.
Hold on. The multiverse. Like parallel universes where different versions of ourselves are living out different lives.
Right.
That's some serious sci-fi stuff.
It sounds like science fiction, but it arises directly from the math of quantum theory. In fact, the way quantum theory so accurately predicts experimental outcomes
Yeah.
points strongly towards the existence of multiple universes.
So we're not just talking about like a philosophical idea here, but a potential consequence of our best scientific understanding of reality. Okay, my mind is officially blown. Help me wrap my head around this. How do these shadow photons and single particle interference experiments actually demonstrate the existence of the multiverse?
Okay. So imagine you shine a light through two slits.
Sure.
Classical physics would predict two bright spots on a screen behind the slits.
Right.
But in the quantum world, you get what's called an interference pattern, multiple bright and dark bands. It's as if each photon is going through both slits, simultaneously interfering with itself.
Okay, yeah, I vaguely remember that from like my physics class.
Yeah.
But how does that imply multiple universes?
The interference pattern arises because each photon isn't just going through both slits in our universe, it's going through all possible paths in multiple universes.
Okay.
The different universes interfere with each other, creating the pattern we observe.
So in a way, we're seeing the shadow of these other universes in the interference pattern.
Exactly. And it's not just limited to photons. This interference has been observed with electrons, atoms, and even molecules, suggesting that the multiverse is a fundamental aspect of reality, not just a theoretical quirk.
Wow. Okay, so we've got this hidden reality, a multiverse teeming with countless possibilities.
Right.
How does quantum computing fit into all of this?
So quantum computers leverage these very same quantum phenomena, superposition, entanglement, and interference, to perform calculations that would be impossible for classical computers. They're not just faster versions of our current computers, they operate on fundamentally different principles.
So instead of just bits, which are either 0 or 1, Quantum computers use qubits, which can be both 0 and 1 simultaneously thanks to superposition.
Precisely. And this allows them to explore a vast number of possibilities simultaneously, giving them an incredible advantage for certain types of problems.
It sounds like we're just scratching the surface of what quantum computers can do. Are there any concrete examples of how they're already being used or how they might be used in the future?
Yeah, one of the most exciting areas is cryptography. Modern encryption relies on the difficulty of factoring large numbers, a task that would take classical computers an impractical amount of time.
Right.
But a quantum computer, using what's called Shor's algorithm, could crack these codes in a fraction of the time.
So all our online banking, secure communications, everything that relies on encryption could be vulnerable to quantum computers.
Potentially, yeah.
That's a bit unsettling.
It's a potential concern, but it's also driving innovation. Researchers are already developing new encryption methods that are resistant to quantum attacks. It's a constant arms race between code makers and code breakers.
It's amazing to think that these seemingly abstract ideas from quantum physics could have such real-world implications,
Yeah,
impacting everything from national security to our everyday digital lives.
absolutely.
This is all incredibly fascinating, but I have to admit my head is spinning a bit. We've gone from shadow photons to the multiverse to quantum computers that can crack unbreakable codes. Can we take a step back for a moment and talk about what this all means? Why should we care about these mind-boggling concepts?
That's a great question. Deutsch argues that understanding these ideas isn't just about acquiring knowledge for knowledge's sake. It's about grasping the profound implications they have for how we view the world, our place in it, and the future of humanity.
All right, I'm ready for another dose of profound implications. What does Deutsch say about the significance of knowledge in this vast and seemingly indifferent universe?
He argues that life and the knowledge it creates are not insignificant even in a universe as vast as ours. He even goes so far as to suggest that knowledge could have an impact on the fate of stars and galaxies.
Okay, now you're really grabbing my attention. How could our knowledge possibly influence something as massive and distant as a star?
Well, take our own sun, for example. We know that it will eventually exhaust its nuclear fuel and enter its red giant phase, expanding and engulfing the inner planets.
Right.
But Deutsch points out that the exact details of this process, the timing and extent of the sun's expansion, might depend on the actions of intelligent life.
So we're not just passive observers of the cosmos.
Right.
We could potentially become active participants in shaping its destiny.
Exactly. If humanity survives long enough and develops the knowledge and technology to manipulate stars,
Yeah.
we could alter the sun's evolutionary path, perhaps even preventing the Earth's destruction. It's a powerful argument for the potential impact of knowledge, even on a cosmic scale.
Wow. That's a pretty powerful argument for the significance of knowledge. It's not just about understanding our world, it's about potentially shaping its future, even on a cosmic scale.
And this leads us to another mind-blowing concept that Deutsch explores in The Fabric of Reality, the omega point theory. It's a theory proposed by Frank Tipler that combines quantum physics, cosmology, and the Turing principle to paint a radical picture of the universe's ultimate fate.
Okay, I'm all ears. What is this omega point theory and how does it tie into everything we've been discussing?
Imagine a universe where intelligence doesn't just survive, it thrives.
Oh,
A universe where knowledge creation continues even as the universe itself collapses in on itself. Tipler argues that as the universe approaches its final moments, it becomes increasingly organized, allowing for ever more complex and rapid computation.
so even as stars die and galaxies collide, intelligence finds a way to persist, to evolve, to become something even greater.
That's the essence of the omega point theory. It suggests that the end of the universe isn't an end at all, but a transformation, a merging of intelligence with the cosmos itself, a point of infinite knowledge and complexity.
Wow, that's a lot to process.
Yeah.
It's almost like a religious idea, but grounded in scientific principles. It makes you wonder, is there a purpose to the universe? Is it all leading to this omega point?
Those are big questions, ones that philosophers and scientists have been wrestling with for centuries. And while the omega point theory is highly speculative, it forces us to confront the ultimate limits of knowledge and the role of intelligence in the grand scheme of things.
I think I need a moment to absorb all of this. We've covered so much ground already, from the foundations of quantum mechanics to the far reaches of the multiverse and the mind-bending possibilities of the omega point. Where do we go from here?
Let's delve deeper into how quantum physics challenges our everyday understanding of time. Deutsch proposes a view where time doesn't flow in the way we usually think of it. Other times, he argues, are simply different universes. And this has profound implications for how we understand concepts like free will and even time travel.
Time travel? Seriously? Okay, after everything we've discussed, time travel almost seems tame in comparison. But I'm definitely intrigued. Let's dive into that next.
Welcome back. Last time we were grappling with some truly mind-bending concepts. Shadow photons, the multiverse, and the omega point theory. Now let's shift our focus to how Deutsch tackles the concept of time.
Okay.
He proposes a view where time doesn't flow in the linear way we typically imagine. Instead, other times are simply different universes.
Okay, I have to admit, this is one of those concepts that makes my brain do backflips. How can other times be different universes? Doesn't that contradict our everyday experience of time moving forward second by second?
Think of it this way. Our intuition about time flowing is based on a limited classical perspective.
Okay.
But in the quantum realm, things work very differently. Imagine a film strip, each frame representing a different moment in time.
Mm.
From our perspective, we experience these frames sequentially,
Right.
creating the illusion of a flowing timeline. But in the multiverse, all those frames exist simultaneously, each representing a different universe with its own unique set of outcomes.
So it's not that time is moving forward, it's that we're moving through different universes, each representing a specific moment in time. That's a pretty radical way to rethink our understanding of time.
It is radical, but it elegantly resolves many of the paradoxes that arise from our classical view of time, especially when we consider the possibility of time travel.
Oh, okay.
Deutsch uses the concept of virtual reality to illustrate how time travel could work within this multiverse framework.
Virtual reality and time travel.
Okay.
You've got my attention. How do those two concepts connect?
Imagine a VR experience so advanced that it could simulate not just different places, but different times. You could put on a headset and find yourself walking through ancient Rome, interacting with historical figures, experiencing that era as if you were truly there.
That sounds incredible. But wouldn't that just be a simulation, not actual time travel?
True, it wouldn't be physically traveling to the past. But Deutsch argues that a sufficiently advanced VR generator, based on the principles of the Turing principle, could create a simulation so realistic that it would be indistinguishable from the real thing. It would be like stepping into a different universe, one where a different set of outcomes had played out.
So I could go back in time, make different choices, see how those choices impact the course of history, all without creating those pesky paradoxes we see in time travel movies.
Exactly. In this virtual reality time travel scenario, any changes you make would only affect that specific branch of reality, that particular universe within the multiverse.
Okay.
It wouldn't alter the past you remember or the universe you came from.
That makes sense. It avoids those logical conundrums where you go back in time and accidentally prevent your own birth.
Yeah.
But even if it's just a simulation, what are the implications of this kind of virtual reality time travel?
Think about the potential for learning and understanding history. We could immerse ourselves in different historical periods, experience them firsthand, and gain a much deeper understanding of the forces that shaped our world. It would revolutionize education, research, and even entertainment.
It would be like having a time machine in your living room. But beyond just experiencing history, could we also learn from it in a practical way? Could we bring back knowledge from those other universes?
That's precisely what Deutsch proposes. He envisions a trade in knowledge where we could access the accumulated knowledge of those other universes, learn from their successes and failures, and bring back valuable information that could advance our understanding of science, technology, culture, everything.
It's a tantalizing idea to tap into the collective wisdom of countless universes,
Right.
to learn from the paths not taken, to accelerate progress in ways we can't even imagine. It makes you wonder if actual physical time travel might be possible one day, even if it seems impossibly far-fetched right now.
Yeah. The possibility of physical time travel is certainly more speculative. But Deutsch argues that the virtual reality scenario helps us understand the nature of time travel itself.
Okay.
It shows that the concept, at least in principle, is logically coherent.
Yeah.
It's not inherently paradoxical or nonsensical, and it highlights how the multiverse model elegantly resolves the paradoxes we typically associate with time travel.
So time travel isn't about changing the past, but about exploring different versions of it, different branches of reality within the multiverse. It's a way of expanding our understanding of the vastness of existence, recognizing that there might be countless other possibilities playing out alongside our own.
That's a great way to put it. And this exploration of time and time travel brings us back to Deutsch's central argument about the significance of knowledge,
Oh, okay.
even in a universe that often seems indifferent to our existence.
You mentioned earlier that Deutsch believes knowledge could have an impact on the fate of stars. Can you elaborate on that? How could something as small and seemingly insignificant as human knowledge possibly influence the course of cosmic events?
He uses the example of our own sun. We know that it will eventually exhaust its nuclear fuel and enter its red giant phase,
Right.
expanding outwards and engulfing the inner planets. But Deutsch suggests that the precise details of this process, the timing, the extent of the expansion, could depend on the actions of intelligent life.
So our actions, our choices, our knowledge could potentially influence the fate of our sun. That's a pretty profound responsibility.
It is. If humanity survives long enough and develops the knowledge and technology to manipulate stars, we could potentially alter the sun's evolutionary path,
Hmm.
perhaps even preventing the Earth's destruction. It's a powerful argument for the potential impact of knowledge, even on a cosmic scale.
It's both terrifying and exhilarating to think that we might have that much power. It makes you realize that knowledge isn't just about understanding the world. It's about potentially shaping its future.
And this connects to the idea that knowledge has a special status in the multiverse.
Okay.
While matter and energy might be spread randomly across different universes, knowledge-bearing structures, things like DNA, brains, books, computers, seem to exhibit a remarkable regularity, a kind of persistence across those different branches of reality.
So knowledge acts as a kind of connecting thread through the multiverse, a unifying force amidst all the randomness and chaos.
In a sense, yes. It suggests that knowledge is more than just a human construct. It's a fundamental aspect of reality, something that transcends individual universes and connects them in ways we're only beginning to understand.
This is all so mind-boggling. I'm starting to see how these ideas from quantum physics and computing aren't just abstract theories, but they could have profound implications for how we view ourselves, our place in the universe, and the possibilities that lie ahead.
And this brings us back to the omega point theory.
Okay.
Remember, Tipler argues that the universe is structured in a way that allows for the continued growth of knowledge and complexity,
Right.
culminating in this omega point of infinite knowledge and intelligence.
It's a concept that stretches the boundaries of our imagination. But even if the omega point remains a speculative idea, it raises profound questions about the ultimate destiny of knowledge, intelligence, and the universe itself. It makes you wonder, what is the role of consciousness in all of this?
That's a question that Deutsch tackles head-on in his exploration of the relationship between the physical world and the realm of ideas, values, and consciousness. And it's a question that leads us to one of the most challenging and important topics in the fabric of reality, the challenge of reconciling moral values with the scientific worldview.
Okay, now we're getting into some really deep waters. I'm ready to dive in and explore how Deutsch connects these seemingly disparate realms of science and morality. Welcome back to our deep dive into the fabric of reality. We've been exploring how quantum physics and computing challenge our understanding of everything, from time and reality to the potential of human knowledge. But now let's tackle a question. It's fascinating, but it's also kind of daunting. How do moral values fit into this scientific worldview?
Yeah, it's a question that becomes even more pressing as we consider the rise of technologies like artificial intelligence. If we can create machines that surpass human intelligence, what values will guide their actions?
Right.
And can we even ensure that those values align with our own?
It's a bit like opening Pandora's box, isn't it? We unlock these incredible technological advancements,
Yeah.
but we also unleash a whole host of ethical dilemmas. So how does Deutsch approach this challenge? Does he think it's even possible to reconcile morality with a scientific worldview?
He does, and his approach is surprisingly optimistic. He argues that moral reasoning can be just as rigorous and evidence-based as scientific reasoning. Instead of relying on tradition, intuition, or religious dogma, we can approach morality as a problem-solving endeavor, seeking explanations that are consistent with our experiences and observations.
That's interesting. So instead of just accepting moral pronouncements from authorities, we should be questioning those pronouncements, testing them against our understanding of the world, and constantly refining our moral compass.
Exactly. Deutsch suggests that we develop moral theories,
Okay.
test them against our experiences, and revise them as needed. It's a process of seeking better explanations for how we should act in the world, just as science seeks better explanations for how the world works.
Okay, I'm starting to see the parallel.
Hmm.
But how do we actually test moral theories. It's not like we can run experiments in a lab to see which ethical principles hold up.
You're right. We can't run controlled experiments in the traditional scientific sense,
Yeah.
but we can examine the consequences of different moral principles, both in our own lives and throughout history. We can look at societies that have embraced certain values and see whether those values have led to flourishing or suffering. We can analyze ethical dilemmas and see which principles lead to the most just and compassionate outcomes.
So it's a process of ongoing reflection, observation, and analysis, a kind of real-world testing ground for our moral beliefs.
Precisely. And just as scientific progress leads to a deeper understanding of the physical world, moral progress can lead to a deeper understanding of what it means to be good, to live a meaningful and ethical life.
But if that's the case, why is there so much disagreement about morality? Why do different cultures, different religions, different individuals often hold such wildly different views about right and wrong?
Deutsch would argue that these disagreements reflect the fact that we're still in the early stages of moral development. Just as our scientific understanding has evolved over centuries, our moral understanding is also evolving. We're constantly refining our theories, learning from our mistakes, and striving for a more complete and consistent ethical framework.
So it's not about finding the one right answer, but about continually seeking better answers, recognizing that our moral understanding is always a work in progress. It's a journey, not a destination.
That's a great way to put it. And Deutsch sees this process of moral exploration and refinement as crucial if we are to navigate the challenges of the 21st century. Challenges that involve artificial intelligence, biotechnology, climate change, and a host of other complex issues. He believes that scientific progress without moral progress is not only unsustainable, it's potentially dangerous.
It's a sobering thought. We can unlock all these incredible technological advancements, but without a corresponding advancement in our moral reasoning, we risk creating a future that's not only technologically advanced, but also ethically bankrupt.
That's why Deutsch emphasizes the importance of values like reason, tolerance, and open-mindedness. He believes that these values are essential for both scientific and moral progress, allowing us to engage in constructive dialogue, challenge dogma, and embrace new ideas.
So it's not just about what we know, but how we think.
Right.
It's about cultivating a mindset that's curious, skeptical, and compassionate. A mindset that allows us to grapple with complex ethical challenges in a thoughtful and nuanced way.
Exactly. And Deutsch believes that this mindset, this commitment to reason and evidence, is not just a tool for understanding the physical world, but a guide for living a meaningful and ethical life. It's a way of approaching the world with both wonder and responsibility, recognizing that our actions have consequences, not just for ourselves, but for others, for future generations, and perhaps even for the universe itself.
This deep dive into the fabric of reality has been, well, an incredible journey. We've explored mind-bending concepts, grappled with profound questions, and gained a whole new perspective on the nature of reality, knowledge, and even morality. It's a book that challenges our assumptions, expands our imagination, and leaves us with a sense of awe and wonder at the vastness and complexity of the universe we inhabit.
And perhaps most importantly, it leaves us with a sense of hope. A belief that we have the capacity to understand the universe and our place within it, and that we can use this understanding to create a better future, not just for ourselves, but for all intelligent life, wherever it may exist.
It's a powerful message, and one that really resonates, in a world that often feels chaotic and uncertain. To all our listeners out there, if you're looking for a book that will make you think, make you question, and make you see the world in a whole new light, we highly recommend David Deutsch's The Fabric of Reality. It's a journey you won't soon forget.
Until next time, keep exploring, keep questioning, and keep seeking those deeper explanations that illuminate the fabric of reality.